Hello, again Rajesh Kumar from AIC. This time we are going to discuss the last type of structural isomerism, that is called tautomerism. It is one of the important structural isomerism. It is the type of isomerism in which the substance exists in two radially interconvertible forms or structure, and both exist in equilibrium with each other or dynamic equilibrium with each other. This isomerism is caused due to the oscillation of the hydrogen atom within the molecule with the necessary rearrangement of the multiple bond and single bond, that is of double bond and single bond. In this isomerism, there is reversible intramolecular rearrangement. In this isomerism, two forms of a molecule are in equilibrium and both forms have the two different functional groups. Since both forms are in equilibrium, so the separation of the two different functional groups is a bit difficult. In this type of isomerism, there is no change in bond length because they are in equilibrium. One form may be less stable, another form may be stable, more stable. The less stable form is called labile form. One of the best examples of this type of isomerism is keto-enol tautomerism. It is not only the keto-enol tautomerism but also other tautomerisms are available here, as for example nitro-Si tautomerism. This is nitro form and this is your Si form. Sorry, write down here nitrogen. Si form. And another one is nitroso and oxymino. Oxymino form also nitrile and isonitrile form. These all are the tautomers and this is called tautomerism. Okay, so here in this every example we see that the alpha hydrogen is going to oscillate between two polyvalent atoms within the molecule. So due to the oscillation of hydrogen atom between the two polyvalent atoms within the molecule, this type of isomerism is caused. The traditional example of tautomerism is keto-enol form of tautomerism. We will cite the example of the keto-enol tautomerism and we will discuss about the stability of the keto-enol form of the tautomerism. Come on here, let's proceed further. Keto-enol tautomerism. In case of keto-enol tautomerism, hydrogen present on the alpha carbon oscillate between the keto form as well as alpha hydrogen. This is called keto-enol tautomerism. Now, the types of tautomerism. It is of the following two types. This type is classified on the basis of the number of atoms covered by hydrogen during the oscillation. One is called diad, another is called triad. Diad, if the oscillation of hydrogen atom covers two atoms, this is called diad. As for example, HCl and CNH. This is called diad. Here the hydrogen oscillates between the carbon and nitrogen. This is called diad. But ketoenol, it is triad because the oscillation takes place between three atoms. One is alpha carbon, carbonyl carbon and oxygen. This is called triad. And these all are catalyzed either in the acidic medium or basic medium. So for this very type of tautomerism, medium, catalyst medium is important factor which one is stable. Hello, again here. We are going to continue in the last chapter, that is called ketoenol tautomerism. Last time we have discussed what is a tautomerism and we cited the example of the ketoenol tautomerism. Ketoenol tautomerism, this time we are going to explain 11 of the things about the ketoenol tautomerism and intricacy of the ketoenol tautomerism. In case of tautomerism, there are two forms. One is keto form, another is enol form in case of ketoenol tautomerism. And both are in equilibrium. At equilibrium, both have a different concentration. The concentration of enol form at equilibrium is called enol content. This is called enol content. The enol content or enol form percentage at equilibrium is called enol content. Now, there are so many factors responsible for the stability of the keto or enol form of the tautomerism or enol content of the tautomerism. That is, one factor is nature of solvent, another factor is temperature, and most important factor itself is the stability of the molecule or the presence of acidic hydrogen or active methylene group. One example is here. See this very molecule. Here in this very case, the methylene group is highly active and this hydrogen is highly acidic in nature. That's why this type of molecule always exists in enol form around 98%. As the activity of methylene group decreases, the enol count decreases there. Means as the acidic nature of hydrogen decreases, enol content is going to decrease there. Take the example of acetone. It is a keto form and enol form could be here like this, but the enol content will be only 0.01% here. So the activity or active methylene group makes enol count greater there. Another factor that is responsible for the stability of ketoenol tautomerism is the intramolecular hydrogen bonding. For example, in this case, molecule is going to make H bonding, intramolecular hydrogen bonding, and that's why it is a 6-member ring, and 6-member ring is highly stable. That's why its enol count is very high, around 80% and more enol count is there. 80%, yeah, 80 to 80% or more than that one. Another example is here, the steric effect. The steric effect is also very important to determine the stability of keto form or enol form. Take an example here. Here in this case, there are two bulky groups are present at alpha carbon, which makes molecule highly strained. And since this carbon is in sp3 hybridization, bond angle is 109 degree. That's why it is highly steric in nature, and steric hindrance effect or steric strain is very predominant there. But when it gets turned into enol form, this bond angle has increased up to 120 degree rather than 109 degree. That's why this makes molecule less steric strain, and that's why molecule is more stable. So enol count will be here greater in this very case rather than keto form, and makes molecule more stable. So there another one is conjugate system. If there is a conjugate system happens, enol form is considered to be more stable than keto form. I'll take an example here. It is keto form, but if it get tautomerized into enol form, the conjugate system appears here. So due to the presence of conjugate system, enol form is said to be more stable than keto form. So there are so many factors responsible for the increase in enol content and so on. Thank you very much.